This video is for the accuracy of linear function models. We're going to use Scatterplots today to determine if our function models are accurate. So our first set of data. The table shows the population of Cedar Creek for each year since 2017, determined using average rates of change. The function p of x equals 3400ths x plus 0.2 could model the population data where x is the year since 2017 and p of x is the population of Cedar Creek. Graph p of x and create a scatter plot of the data to compare the linear function model to the given data set. All right, so what we're going to do. First thing, we're going to graph our points, okay? So here, let's see, I think these are 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. We're going by tenths. So if you need to label, you can. You don't have to. Once you get past 1, it'll be 1.1, and you'll go up. All right, so we've got a point at 0 and 0.2, 1 and 0.5, 2 and 0.9, 3 and 1.2, 4 and 1. See, 2, 3, 4, 5, 6, and then 5 and 1.9. So that's the scatter plot of my data. To graph this line was found, this equation here, using average rates of change. So with a ruler, you can just connect the first and last data points and continue to go through. And the reason that we're starting at 0 is that's where our data starts. We could go back, we could extrapolate data if we wanted to. In this case, we don't really need to do that. Okay, so the graph shows the given linear model, p of x, that's this line, approximates the data set closely. All those points are very close, if not right on top of those lines. So p of x is an appropriate function model for the data set. So if those points fall pretty darn close, then you've got a good model there. So our next set of data shows the population of Cedar Hill for each decade since 1950. That should say 1960. I don't know why I have all these boo-boos. Determined using average rates of change, the function q of x equals 8.66x plus 1.8 could model the population data where x is the decade since 1960 and q of x is the population of Cedar Hill. Graph q of x and create a scatter plot of the given data to compare the linear function model to the given data set. Okay, so we're going to graph all this data. And so these are counting by ones here. So your dots are going to kind of be messy here. So 0 and 1.8, if that first line is 1, that second line is 2, it's going to be kind of below it there. 1 and 2.6, about halfway in between what would be 2 and 3. Again, if you label 1, 2, 3, 4. Again, it's real small. I apologize for that. 2 is 6.8, so 5, 6, 7, so in between there. 3 and 19.9, so almost to the 20 line. 4 and 32.1. 5 and 45.1. Okay, so if we graph the line, again, it's doing average rates of change, so we just take the first and the last points and connect them, and that would be the line. That's the q of x in this case. So if we look at this one, the graph shows the given linear model q of x. This line overestimates most of the data. Most of our point falls below that line, meaning that line overestimates most of the data set. So q of x is not an appropriate function model for the data set. So if majority of the points are not close to that line, it's not going to be an appropriate function. If maybe one, if you've got one oddball, that's different. But again, most of this data is way under that line.